What the hell is going on in here?
In a world where hackers are working day and night to infiltrate your network, Jay and Penny are here to talk about it. Welcome to the Order of the Cipher. Let's just say...
Well, it's true. It has happened. The experience you mentioned where I walk in, I expect to log on, and my computer's already open.
Yeah.
Huh. That's odd.
That's odd. Does anyone know your password?
No.
No.
No. And what makes it especially odd is that we had, after 5 minutes of inactivity, by policy, it was set to lock.
Is it possible that you scared away like a rat? I was going to say mouse, but you'd have a mouse under it. Of course you'd have a mouse right there.
Of course I have a mouse. Well, I was on the 3rd floor.
Yeah.
Not very likely.
Known for being rat infested.
No. In Alaska, earthquakes happen and the building is on rollers. So the higher up you go, the more you feel the earthquake. However.
Because it couldn't be hackers. It's earthquakes.
That's odd.
But if it was hackers and they had gotten in, why would they be coming after you?
Oh, I mean, I'm an admin on all of the computers. I have access to some of the servers, but I'm an admin on all of the workstations, right?
Totally.
That might get you somewhere with something.
Yeah, this is like the essence of social engineering attacks, right? I don't need to defeat your encryption like I'm in the movies. I just need to call the right person and say, I can't get into this presentation. You got to give me my access right now. And, you're flustered. And
I also am part of the group that creates all of the accounts for any user.
You're a target.
Why would I be a target? I sit behind my desk all day long. Why would that make me a target?
Because you've got access to the passwords. You're like the oracle of passwords. If they get you, they can go after the CEO.
I'm so boring. Why would they target me?
See, and that's
why they target me.
That's why they target you. Because they're like, hey, we have this exciting thing and you're going to save the day. And you're like, oh my gosh.
You have to help me. I have this customer, millions of dollars, crap and stuff going on.
Yeah.
You have to make it happen.
My day is brighter. Like, thank you.
Right.
You're thanking the hacker now for...
Right. I'm so happy that I was able to help you with this $1 million deal and making it happen and bottom line. And I can already imagine the bank people, the top bank people patting me on the back and being super happy with me.
Yes.
I can see it in my brain.
Yeah.
I can see it.
This is literally what happens. We're making it extra, but...
We're going a little over the top.
Yeah, just a smidge. But that's
just a smidge.
That's totally what happens. So let's just say that you wanted to, I don't know, wedge a 400 million pound ship in a canal. Maybe the Suez, just to pick one at random. Do you hack the GPS receiver, the autopilot system, the drive-by-wire, meaning the wheel in the bridge? You could hack the firmware in the motors that are...
I get to pick which one we're hacking?
Yeah. And
are there more options?
Well, there's the display screens on the bridge because everything could be doing
channels,
what you say.
The display screens are showing the depth of water and the hills and valleys underneath, right? That we can't see with our own eye, but they're sending waves of stuff down there.
Yeah. They're telling you that
I want to hack that one.
You think your heading is 145 degrees and it's actually 140 and you're slowly drifting
into that big water-covered sandbar.
Yep.
That's right there.
And your ship into the sand.
This has happened. I mean, I'm not sure about the hacking part, but drifting into sandbars and fishing vessels being caught up on them.
Yeah.
That has happened.
And so once upon a time, there was a military ship that was running on Windows, and the entire ship got bricked.
Oh my goodness.
Windows just took a crap
As it does.
Yes.
On occasion.
This was back, this is back when I was really into like Linux and stuff. And so everybody in the forums was like, you should have been running Linux, it's reliable and Windows is crap.
I mean, it happens elsewhere too, but
it happens a lot. So, and so they had to tow it back to port. They just had this is like the argument with electric vehicles, autonomous vehicles, right? What if you can hack those and
not even just electric autonomous vehicles. There are so many things inside vehicles now that are software driven. If you can hack any one bit of that, you can control the whole thing.
So what a great, that brings it back to this scenario, because there's all these different pieces in the chain. In order to get that ship going straight, there are so many different software systems and firmware systems that all need to be working right. And every one of those is exploitable, is hackable. Where would you do this is another thing, because let's say you just, the ship has internet, right? My cousin worked in Antarctica, and they would send an email, which actually meant that it got queued up, and the satellite would pass over and all the data would exchange, and that was it for the day.
Totally makes sense.
So you've got this ship, this big container ship, and it's going around the world, and let's just exclude the internet. We're not going to use the public internet. So you've got 3 different ways still that you can hack this thing, because what we do, especially on industrial systems, is I have a printer that spits out a Wi-Fi signal so that I can connect directly to the printer.
I printed to your printer from my house like 30 miles away. It was an accident. I didn't realize I was still connected to your printer, but I did.
You hacked my printer?
I know. So I know that can happen because I did it.
Okay. So like 3 weeks ago, our piano started playing. It also spits out its own Wi-Fi signal. Was that
me.
You? That wasn't.
No, that wasn't me.
Okay.
You need to look for somebody else though.
Okay. Someone, a musical hacker, some sort of talented musical hacker. So this ship, we could hack this while it's sitting in dry dock, because it's got equipment on it that is emitting Wi-Fi and Bluetooth and
people coming in to fix the thing and to tweak the thing and to make sure it's ready for sailing and all that.
Someone comes in, hey, what are you doing in there? You're like, nothing.
They got a blue jumper on. They got a clipboard. I'm letting them in.
Yep, exactly. You could even do it at sea, right? You just need to be within radio distance of this thing. So they're gonna probably think you're a pirate and shoot at you, but not if you're wearing blue jumpers with clipboards.
Right.
You're gonna be fine. So I was reading up on this ship sideways in the Suez, and there was a line that kind of stuck out to me. It said, Russia's energy ministry said on Monday a stranded container ship blocking Egypt's Suez Canal has highlighted the safety and sustainability of the Northern Sea Route and Russian energy pipelines.
I hadn't realized the Russian energy pipelines. However, seeing all the little maps and graphs of all the ships that have to be rerouted now and how much longer it's going to take for them to get with their goods from where they're at now, circling, waiting for, big ship to get out of the way. And in the future, if this takes a fair amount of time, then delivery of goods is going to take weeks longer than it used to, potentially.
Yeah. I read somewhere that, but I have no idea if this is accurate or not. I just kind of caught it in passing. $10 billion in goods is on those ships. All the ships that were waiting, and they're not waiting anymore, by the way. I don't know if you caught that.
People are quick to find workarounds and how are we going to mitigate and that kind of thing. So I expect that instead of like, all right, you have to sit there for the next days or weeks or months while we're working on getting the ship free, they were going to come up with something. So it doesn't surprise me.
Well, let's just say.
Twitter talk.
So what's happening, at least in understanding what Scott Piper was talking about on Twitter, is that AWS is starting to add an inline policy to access keys that it sees out in the world. So if it discovers an access key set that's in a GitHub, GitLab, or some web page somewhere, they are stepping in and editing the policy on your behalf. And the original idea of AWS stepping in and editing policies was to prevent Bitcoin miners spinning up an EC2 instance and charging you a tremendous amount of money. But now they're seeing fit to also add inline policies to prevent world-readable S3 buckets. That's really part one is, should AWS be doing that? Obviously, they think they should. And then part two is that they did this change without a CloudTrail record. So they changed something in the environment without that being recorded. And
so
that's
they
a compliance.
reached into my personal stuff, made a policy, put it in there, and didn't leave a record of when that happened.
Exactly. So now, not to be, I don't want to be pedantic about this stuff, but you've got compliance requirements, and AWS is now violating your compliance requirements. They're making changes that are unrecorded.
When did this change, or when did this get added to this user? That's all in regulated industries. That is, you have to be able to show when changes like that happen.
Yeah. Now, this is just an event that happened and people noticed it, and I'm sure that AWS will improve. I mean, we can make it sound very dramatic, like they're going around willy-nilly making changes, but
they did, and they can, because not this specifically, however, opt-out policies for new regions.
Yeah, that's been an issue in the past.
That's a default setup, so similar but different.
Did you hear about that one that happened recently with... was it Osaka? AWS, I think it was with the AI tools. So there's, that's the one. We're talking about the same thing. So we'll inform what we're talking about is that AWS had a data sharing policy that by default would allow your data to be included in their AI analysis. So where this comes up is like Macy and GuardDuty, they want to take a peek at the traffic that you're sending across the network so that they can analyze what's normal versus abnormal. I don't assume that any of what's going on here is nefarious. I just assume that it's
probably not
thought out in detail, right? Okay, so they have this policy about artificial intelligence, and they tell you that in new regions, by default, it will be off.
Mm-hmm. They promised. And then in Osaka, it was not off. And the logic, I'm missing a few little details in here because I don't know quite how that jump got made. But basically, like Osaka predated these other regions where this applied. And so basically someone did something automatically, and they just kind of lost track of the fact that we told people that this wouldn't happen, and we forgot about this corner case situation where some region that existed previously and now everybody gets access to it, and suddenly your stuff's included. And again, it's who's truly affected by this? I do kind of wonder who is truly affected by this. My data.
Well,
I want to choose if I'm sharing my data. I don't know where. I don't know where I'm sharing it, but if I have a choice, I don't want to share it.
Yeah, and I get that, but I don't know. These are we're exploring the limits of trust here, right? We're putting our data in AWS, and we're entrusting that they have our best interests at heart. And Macy and GuardDuty seem like they have our best interests.
I was putting my data in AWS based on the fact that it's mine. Nobody can get in.
Right. And that's why they have encryption everywhere.
End to end.
End to end. Mm-hmm. Plus, Enclave, our little side thing that I just love so much. I think it's so cool.
The Nitro darling.
Yeah. Well, and that's what's been happening on Twitter.
The dark side.
So I read recently that the National Cybersecurity Center has reported that fully 1/4 of the hacks in the last year are related to COVID.
How does a quarter are related to COVID?
Yeah.
Are we hacking hospitals? What does that mean?
Not only that, but a fair amount of those are nation states. Nation states doing hacks based on COVID. Their universities, their supply chain. This is health related.
Whoa.
And it is impacting people. It's impacting potentially people that we know.
They're targeting resources, supply chains, etc. These are things that are COVID specific, but that's where the opportunity is. Is it economic? Are they stealing, the formulas, or is it
The University of
ransom?
California, San Francisco paid $1.14 million, and they negotiated down to get their research data unlocked. That was ransomware. But
I wonder what they negotiated down from. That could have
3
been
point something.
Oh
I
my
forget
God.
the exact number, but it was 3 point
hang on.
something.
I gotta
that
go
they-
change careers. I'll see y'all later.
Right. So they've found evidence from Russian hackers, North Korean, Chinese hackers. They're going after data. They're going after, supply chain. I assume it's economics, because people who are trying to get the virus either produced or delivered don't have a lot of time to I'm gonna fix the thing that got broken that let you into my stuff.
Yeah.
So they don't have a lot of time, and now we are impacting the ability of medical professionals or researchers to provide health and well-being. We're impacting lives here.
Yeah. This is what I really love capturing in our Order of the Cipher courses is, in my day, you were hacked almost for sport. And then ransomware came along, and it was a novelty, and a few people got it. Now it happens all the time. And now it's shifting into, they really want to get you in what matters. It's not encrypting your Excel sheets. That hurts.
Right.
But this is getting into just outright, cruel intentions.
The thing that's even worse is that they are so sophisticated. They're so sophisticated about this. They're using spear phishing. They're using malware on Androids to imitate contact tracing, and then putting remote access technologies onto people's Androids. And they're using ransomware.
Yeah.
And the evolution of these hacks and these attempts just gets more and more sophisticated. And how do we continue to fight against them? How do we protect our vulnerable people? How do we protect our data, our resources, our money?
Yeah.
They get in now, and they don't immediately encrypt your stuff. They find out how far they can go. Mm-hmm. And then they're
they're
out.
in there for months and months.
Yeah.
Just so they can, they map out your people, they map out your company, they map out your systems.
They make a route out, they make more routes in, and then more routes out.
Because you could get rid of them. This is like a movie where you're like, well, that's all taken care of. We threw the bad guy out the front door, and suddenly they're crashing through the window.
And how do you protect against that? How do you manage your data or protect the people? Like in the healthcare industry, we've heard multiple times about ransomware that shuts down services. Mm-hmm. Mm-hmm. I read an article about a man who died from a heart attack because he had to be rerouted to a different hospital because the one they were going to had a ransomware attack and could not treat him.
Yeah. So, in our storytelling, we take that nugget of reality and blow it up into, that's not just any person. That is the leader of the union of something or other, their
Or that's
political
my
importance
dad.
or business importance, or right, or it's personal, or
Right.
and really kind of drive that message home. Take what individually could seem like chaos or opportunism, and make it targeted, sophisticated, with a purpose, and that's why we do our storytelling the way that we do. Gosh.
Yeah. They craft jobs and put them out on LinkedIn and try to fish the people that respond to the jobs, and either fish them or get them to download hacked malware.
Yep. Tremendous. That's pretty dark.
So I looked at a lot of people, Jay, and I finally settled on Cynthia Brazil.
And what does Cynthia do?
She makes robots. It's super cool.
Oh, fabulous.
I know, personal robots. She's at MIT in the personal robot group.
Does she make the dancing dog?
No, she doesn't make the dancing dog, but she's focused more on social and emotional intelligence. So she's trying to, AI and machine learning are heavy into her research. She's trying to make robots that can be in your home. So the first robot she made is Kismet. And
I've heard of this.
Yes. I figured that you might have. Kismet. And I say he because we assign personality to
It's
everything.
probably part of her research.
Probably.
Okay.
Kismet could have facial expressions. And the next iterations, Leonardo and Nexi, would learn based on interaction with you or whoever they were doing. And she also made another one called Autumn, which was a diet and exercise assistant. People who got this responded better than like online check-ins for food and exercise and that kind of stuff. And then they actually, when they came to collect the robots, told them goodbye. I'm going to miss you. So they developed emotional attachment to these in-home robots.
Got it. So maybe Autumn was asking you, how are you feeling? And did you exercise today?
Yeah. Yeah, what have you eaten today? What is your calorie intake?
This is my from the heart motion. Just you're building that. That's really cool, that connection.
Right. Yeah. She also, I find this very fascinating and empowering. So she, in one of the YouTube videos that I watched, she had been working on the social and emotional impacts and robots and AI and that kind of thing. And Furby came out. Do you remember the Furby toy?
Yeah. Oh, yeah.
So she was really concerned because here she is spending hours and hours and tons of time and money doing the research on the emotional AI for robots, and then Furby comes out. However, Furby's reactions were programmed and were not learned.
Yes.
So then she was relieved that she didn't have to immediately drop all of her research because it's come out in a $20 toy.
Wow.
Additionally, though, she was Joby. Do you remember Joby?
Again, this sounds familiar to me.
It's a in-home personal robot.
Yeah.
She had a company and they were making the Joby. It ended up failing because of Alexa and Google Home, because her robot was more expensive than those. But I find that fascinating and empowering because you have to fail too, right? You succeed at things, but you fail too, and you learn and you keep going. Mm-hmm. So she is currently still at MIT. She's currently still researching and developing in machine learning and AI. And in March 2020, MIT and her group opened up a website for kids who are being at home to continue learning and playing games with STEM. And Jay, how about you?
My woman in technology and science is Özlem Türeci, who is the co-founder of BioNTech, the creators of one of the coronavirus vaccines that's out there right now. So she and her husband, they're Turkish immigrants to Germany, and they had a previous company that they sold for a tremendous amount of money, and went right back into it with BioNTech because they recognized that this mRNA technique would allow for customized cancer treatments. So the mRNA technique, in short, is that we can give the body instructions, incredibly customized instructions that trigger an immune response. So we can extract the cancer that you have, figure out what unique feature of that cancer we can tell the body to look for. We code this mRNA sequence that describes that feature on the cancer cells, inject it into your body. The immune system says, Roger that, we're going to go looking for these things, and finds that cancer. That's the promise, okay? So it's January, this virus, it really, like, if you had the best intelligence, you were hearing about this virus in October and November. I mean, like if you're the government, okay, you got that level of intelligence. You're on top of this thing back in October, November. There were a few public notices in December around virology, and then January, if you're in those worlds, it was definitely something that you were keeping an eye on, okay? So they're in those worlds. So January 24th, they're sitting at breakfast and they make the decision, we're going to stop all of our cancer research, basically all of it. We're going to take the entire company and focus it on coronavirus. We got to get a sample of the vaccine. We got to sequence it. We got to, translate that sequence into, we got to look at it and see what the features are and translate the sequence and see how that coordinates and what's the magic that we're going to look for, and code that mRNA sequence. And then they were, in trials. They are the Pfizer vaccine, Pfizer BioNTech.
Wow.
And that's Özlem Türeci.
The history of hacking.
Penny, I'm pretty excited to tell you this story.
I'm super excited to hear it, Jake.
Now, you might have actually heard it. I mean, it kind of just occurred to me that I don't know if this story is new to you, but I hope that it is. It's one of my favorites, and I think as a kickoff to, this, how did we get here? This history of hacking and computing. It's such a great one. So Cliff Stoll, Stoll, he wrote a book called The Cuckoo's Egg, and it's about what might be the first documented hacking ever. Cliff was working at the Lawrence Berkeley National Laboratory, which is in the San Francisco Bay Area.
Okay.
Not far from Berkeley, the thing that it shares its name with. He was asked to look into a 75-cent discrepancy in a time-sharing system. Time-sharing system, is that something that you've come across before?
I mean, I've sat through the 4-hour presentation, and then we couldn't leave until we had to either sign something or give them the names of our firstborn children or maybe our best friends or something like that. So we stayed another 2 hours to try to, yeah, I've heard of timeshares. Okay. Oh my God, that was so funny. It's only funny because you've either been in it or you've been related in some way to an experience like that.
Yeah. I think what I love is that you went so deep in that. So there was So an early way to share computer resources among people was to have them all have a physical connection into a machine, and it would actually like cycle among them and answer their queries in turn. I mean, the computer works so much faster than a human that from the human perspective, this time sharing system was responding to all of their needs just quickly enough, and it could also churn on problems for people. It could do computations for them, and so you would actually like tee up a computation. You would submit, here's a problem that I want you to solve for me, and once you got your request all batched up perfectly, then you'd send it into the time sharing system, and it would take 10 seconds to compute it.
Right, because it's a computer, yeah.
Yeah, and you'd be charged for that. So Cliff's,
I had no idea.
Old way of doing things. So Cliff's boss said, hey, there's a 75-cent discrepancy in this time sharing log, and who got billed for this? So
How long ago was this?
This was 1986.
So 75 cents was worth how much now?
Like $400, $500 easily. Yeah,
Fair amount. Let's track that down.
So turns out that stuff was really expensive back then. That 75-cent discrepancy was 9 seconds of time.
Right. So this is important. I understand why Cliff's boss came to him and said, track this down.
But also, I was making a joke about how 75 cents is worth so much more. But honestly, think about the price of computing. 9 seconds of compute. I mean, you could get an entire, T3 nano instance at AWS for like $3 a month. I'm totally doing this off the top of my head.
Right.
75
cents would be like, what's smaller than nanoseconds?
Yeah, I mean, that's like 6 days. That's like 6 days of computer time for 75 cents.
Going full bore.
Yeah, going nuts.
Like with the biggest, gnarliest math computation thing for space that you can think of. 6 days.
Yeah, and in the era where, my iPhone has as much computation as like whatever the largest supercomputer was in 1986, my iPhone has like 10 times that much power on it now,
outstrips
right?
it.
So it's 1986, it's 75 cents for 9 seconds of time. This leads into 10 months of Cliff's life tracking this hacker down. So he figures out that someone not only has logged in and gotten some extra time, they are still logging in and getting some extra time.
More money.
They're not using, just to kind of make this a little more relatable, that 9 seconds of time, they're not submitting requests. That 9 seconds is actually a microsecond here and a microsecond there, all compounded together. So what's really going on is over the course of a month, this person is logging in repeatedly, and cumulatively, they use 9 seconds of time.
I've heard something similar, only it has to do with money. So when banks invest to the 500th of a cent or something like that, if you steal just that thing that means nothing to any of us and is not worth anything on paper, but if you have enough of them, you're a billionaire. He was doing that.
Do you know the name of that attack?
No.
I think you're going to like it. It's called a salami attack.
I love it. I'm not sure why it's called a salami attack, but I love that it's called it.
Because you're just shaving a little
you're just shaving it off
the end of the salami.
Yeah, nobody will notice that tiny bit of salami that's gone.
Yeah.
Cliff expects that our hacker is going to be logging in at some point over the weekend.
Okay, so Cliff goes to 50 of his colleagues and he says, I need your computers. I need you to let me borrow your computers and borrow your line printers. And I need to get 50 of them because we have 50 phone numbers and I have no idea which phone number this person is going to use. So he connects all 50 over the weekend and he comes in and he figures out that yes, this person did come in, and now he can start tracking. He knows what line they came in on, and so he takes one of those line printers and he just sets it up to spit out all the data that comes across that line, and nobody else uses that line. So these are phone lines that you would have a modem and you could log into the time sharing system, right? Mm-hmm. So 10 months he watches as this person contacts military bases. So they would dial in on one line and then dial out on another line through the time-sharing system, and they would ping military bases across the country, and they would get in there and try to run database searches for things like the word nuclear or the word SDI, which was the Star Wars, the missile defense thing, Reagan era stuff. So it turned out that military bases had like a whole bunch of trouble where the username would be guessed and the password would be blank. Gets in, does his search for nuclear, does his search for SDI, gets out, nothing to be found. Pulls out the password lists, which were not terribly secure on these systems, and can then do a dictionary attack, which we still have today, where people don't choose random passwords. So if I have a list
you have to be able to remember it.
Yeah. So if I have a list of 1 million actually used passwords, I can run a dictionary attack, and everyone that's got that password, suddenly I know I got your account.
Yep.
So it turned out that this was an operative from West Germany.
Nation state. I was going to ask about that.
Who was selling the information to the KGB.
Oh, the KGB.
Gah. The way that they confirmed that is that they got a piece of mail that, I completely forgot. So there was a problem. How do we figure out where this person is? How can we possibly figure out where this person is?
Right.
They set up a honeypot. So Cliff creates a fake division of the Lawrence Berkeley National Laboratory. And he realizes that this guy he thinks that he's contacted the Lawrence Livermore National Laboratory. Lawrence Livermore works on nuclear weapons.
Oh, that would make sense.
Lawrence Berkeley does
Research.
technical, just computing. And
Yeah.
so he sets up this honeypot. He's got nuclear stuff and SDI stuff, and he just writes,
Come check me out. Come check me
I'm
out.
here. He crafts himself all this bureaucratic mumbo jumbo, military mumbo jumbo for this guy to download. And that gives them enough time to do the old, like, we're tracing the line, and, keep them on the line. Yeah. Jinx. So they figure out he's in West Germany, and they get a piece of mail from, it turned out to be from the KGB, that was politely asking some question that
About the fake information.
About the fake information.
Yep. Yeah.
So
nobody would know this except for somebody that hacked into our fake area.
And in the end, Cliff actually he flew to West Germany and testified in the case against this guy. I think Marcus Hess was his name, and an associate of his that were responsible for breaking into all these military bases. The first, possibly the first documented case
Of hacking.
hacking.
That is fascinating.
Yeah.
That is, super cool in a historical kind of way.
Yes.
Let's talk about white papers.
So Penny, there's a new white paper out from AWS, and what could possibly be more interesting than digging into a white paper? But actually, this one's pretty good. So this is about multiple accounts in AWS. So we're talking about the AWS Organizations service.
Mm-hmm.
We're talking about Control Tower, and we're talking about architecting your AWS environment. Doesn't matter if you're a company that is brand new to AWS or you've been there and you've discovered some of these pain points. You can absolutely use what's covered in this white paper.
This is a multi-account strategy as a best practice from AWS to help for containing blast radius, as they call it.
Yes.
So I'm very interested in any new or pertinent information they may have to share in the white paper.
So one of the advantages, limit scope of impact from adverse events. So there's blast radius right there.
Radius.
Okay. And that's one of 8 different advantages that
Oh
they
my
had.
goodness.
Yeah.
Wow.
I had no idea. Okay. So why don't we just dig into some of that? Another one that I think pretty obvious here is group your workloads based on your business purpose. So you've got, you're a large multinational corporation. You got different divisions. Okay, done.
Also, could that mean like in a smaller company like prod and dev?
Absolutely. That falls under promote innovation and agility. They've got Sandbox accounts and development accounts. And they really distinguish between Sandbox and development in an interesting way. So Sandbox, they say, typically disconnected from your enterprise services and do not provide any access to your internal data. So basically, this is the Wild West in here. This is the cantina from Star Wars.
Everybody's got a gun.
Everybody's got a gun. Development accounts provide limited access to enterprise services and development data, for developers, right? Pretty straightforward. What was the other thing you mentioned?
You mentioned accounts for different areas, and I jumped immediately to dev and prod, but you mentioned like different divisions.
We have constrained access to sensitive data. So for example, you could put all of your S3 buckets that might possibly become public
in one account, and every other S3 bucket that should never be public in another account. Oh, that's good.
Isn't that?
That's good.
Yeah. Oh, I really like this one. This is this is support multiple IT operating models. So what that means is you might have some really advanced DevOps people. They're doing everything great. Infrastructure is code. Nobody touches production.
It's right.
And then you've got the people that just don't know how to do that yet. And they're off in the corner and they have their own account.
We're trying to get better, but we got a ways to go.
They call that traditional.
Oh, yeah. That's definitely my group.
Managing costs, that's reasonable because costs are aggregated at the account level.
And there's no cost to having accounts, right?
Nope.
It's just the resources. So I could have 5 accounts. I could have 50 accounts. It's going to cost me nothing.
Yeah.
It's the resources that I build within the accounts. So, all right, divvy it up.
Yep. There's a reasonable complaint to be made. Hey, I got some management overhead when I have so many accounts. Right. But, that's why this white paper exists. And that's why organizations exist to help you. And Control Tower is there to make that process really easy if you're starting newly. And then the last thing is distributing AWS service quotas and API request limits. So what they're talking about here is, say you have a workload that could blow through a quota.
Like what? What would that be? Because those were all words to me without meaning. So let's dig into that a little bit.
Well, in order to prevent your spend from getting out of control and to prevent AWS from literally running out of resources in an availability zone, everyone automatically has quotas. You have, hundreds of, every little thing has a limit that they put in place. And if you want to go beyond it, you have to make an explicit request to AWS.
The number of EC2 instances I have, or something like that.
If you didn't have these quotas, yes, absolutely. What's to stop you from having an auto-scaling group and saying, the minimum number of instances? Yeah, I want 8,000 instances at a minimum.
And then I have a DDoS attack and it just blows up or something like that.
Yep, that could happen to you as well. So that's what they're saying is, hey, you've got, these quotas are per account. So if you've got stable stuff, no worries. But if you have kind of this service that's just like, I don't know what I'm doing, and it's
wildly random things.
Yeah, then get that into its own account. Those are some of the exciting benefits. And then they were talking about how do you structure this? So in organizations, you have organizational units. So in the AWS Organizations service, you have the root account, and then you can create organizational units, which are containers. Oh, I shouldn't use the word containers because that's a load. We could be talking about Kubernetes all of a sudden.
Right.
So they will, house multiple accounts, and then you can set policies at the OU level. And this is where AWS is starting to, there's new logic that goes into what the hell an OU is for as well. They say, this is not about your org chart at all. This is about finding accounts that share the same policies, that have the same needs. So for example, if you...
Our S3 buckets, our S3 bucket example. Buckets that are allowed out to the public versus buckets that aren't. You can set a policy to the organizational unit that houses the accounts, that has the S3 buckets, that cannot get out to the internet, and make sure that no one ever can set a public policy to allow those buckets out to the internet. Whereas this other organizational unit and the accounts in it are allowed out to the internet.
Yep.
Yeah.
You can enforce tagging policies, backup policies, shared networking. You can create those SCPs and apply them to the organizations that do need it. And then your exceptions, your black sheep, can be outside of the OU.
In their own area.
A couple things that I thought were kind of interesting. If you're going to do any automation around OUs, you actually need to set up a parallel empty organization.
Is this like your dev or your sandbox organization then? So you set up stuff and then you test it and then...
Well, I guess it could be Sandbox if Sandbox means it never accesses any enterprise services. But development, the expectation is that you would have access. You couldn't put them outside the organization completely because they would need to have some access. We could end up with a lot of accounts, and then you got to do it twice because you got to test your automation. If you're going to make SCP changes, do you do that in a live organization?
You don't do that live.
No.
Well, I mean, best practice is you don't do that live.
So now I have to have an entire other organization to get this done. So there's another account in that security OU, which is the security tooling account. So the idea of the security tooling account is, okay, I've got an immutable log archive. Mm-hmm. I have tools that need access to that data, but I can't run the risk of having developers working in the log archive account. I need to ensure that it is immutable. No one can change that data. So the tooling account has services that we need like Security Hub, Guard Duty, Config, IAM Access Analyzer, Detective, Macy, and Firewall Manager.
Those are some really good tools.
All running in one account,
mm-hmm.
only accessed via federated access. So you really don't, most of these things you turn on and configure. You don't need to touch them.
Set it and forget it.
Set it and forget it. Occasionally you might need to step in, and that can be a really tightly change managed process to go in and update any of these services that are running in the security tooling account. And there was one last thing that I thought was really cool around CICD management. Okay, continuous integration, continuous delivery.
Right.
They really called out this point that they recommend you use a set of production deployment accounts within a deployment OU for all your CICD. So you've got a production account and a non-production account, and that's where your workloads are actually running. But you're delivering new code to them. You're delivering new code that needs to be tested in the test account.
Right.
And then once it passes review, that new code needs to be deployed into the production account.
Right.
And what they're saying is the resources that you need to access in order to get the code compile the code, test the code, deploy the code are all subtly different between production and test.
The tools themselves are different?
The things that the tools need to access in order to get their job done are different.
Fair.
If I had production deployment talking to test systems, I can get access to the test system and inject something into the production deployment account that then gets pushed into production. I don't want that.
Right.
Okay. Well, what about the test deployment system being responsible for pushing to the production workload account? Well, I don't want that either, because I can have these cross accounts. So if you really want the ultimate in security, you have to split. Now we take production account, test account,
Sandbox account,
development account, and they all get their own CICD accounts, plus all the security accounts, plus we got to have a whole separate organization that mirrors this thing so that we can do testing. Suddenly, you've got 1,000 accounts.
I was going to say 50,000, but
This is getting
1,000 is still,
this is getting nuts.
right?
But the advantages, if you are that security conscious,
I could see that, but now let's take a look at our little small environment. What are some changes that we might implement based on the information that you've learned?
the security tooling account is something that would be really exciting to see.
Yeah.
We implement these things because we want to explore the best practices of working with AWS, not because we have, we don't have personally identifiable information. We do not have confidential customer data. We do this for the learning exercise. And I think, as we move into our future course on automating security, by that time, I could see, all of this existing, being able to spin up an entire organization for testing, to test the management of the organization itself. I need a test organization.
Right.
Yep. So I think this is a really good white paper. It's AWS speaking authoritatively about what enterprises should be doing in their account structures. It's certainly more than we expected, but if you really want things to be secure, then this is what you need to do. So I think a great white paper from AWS.
Fantastic.